We're going to look at composition of functions. So it'll look like we're veering from talking about inverses, but there is a connection that this has with inverses, but you have to know what this is in order to be able to see that connection. So our composition of function is when you're dealing with two different functions. So when you're dealing with f of x and when you're dealing with g of x, right? So the way that we define our composition of functions is with this right here. So this thing that looks like fog, we really say f of g of x, sorry. So f of g of x. Now it's important that you realize that this is an open circle. Okay, it has to be an open circle. A closed circle means that you're multiplying f and g together, which is not the same thing as a composition of a function. Now, this right here is really what it means. Now, remember, when we have this thing in here, this is our input for f. So what happens, instead of just having a variable or a number for our input, we have an entire function for our input. So you plug one function into another function. Now, we also have to talk about the domain. When you're looking at the domain for the composition, so for f of g of x, it's all of the x's that work for g of x that also work in the domain of f of g of x, so the end result as well. Okay? So it's easier to talk about that when we have an example, so we'll look at that in just a minute. So when we're doing this, it's easiest to see this when you are using colors. Okay, so if we look at our f of g of x, and I'm going to use this sea green color, and then if I look at the g of x as this blue color. Okay? So when it's asking to find f of g of x, I'm really saying find the input of g of x into f. So I always like to start with whatever my outside function is, so the f of x. So I write the f of x, but instead of the x's in the f of x, I'm just going to leave blank parentheses. So I'm going to do blank plus 2, because our f of x is really x plus 2. But inside this blank, I'm going to plug in the g of x. So I'm going to plug in this 4 minus x squared, because that's our input. So then this becomes our f of g of x. Right? So then once it's plugged in, all we have to do is simplify, and we follow our order of operations like we normally would when we're simplifying. Now make sure that since we're not finding the inverse, we're not doing the order of operations backwards, we're just doing the order of operations the normal direction. Okay? So here, the parentheses, there's nothing else to do in there, so then the 4 and the 2 are like terms. So then I just get negative x squared plus 6, so that gives us our f of g of x. Okay. Now when we're looking at the domain, I have to look at the domain for g of x first, because that was our input. So if something doesn't work in our input, it's not going to work overall either. So here, if we're looking at this is a parabola. I know it's a parabola because it's the highest power is an x squared. Since the a value is an unsaid negative 1, I know that this picture is going to be opening down kind of like that. So that means that as I'm going to the left, it's going to be going down. So it's going to the left forever, and it's going to the right for forever. So our domain for g of x is all real numbers. So we don't have any restriction from there. So then I'm going to look at my end result, which is the negative x squared plus 6. This is also a parabola, and it's also opening down. And so our domain is still negative infinity to infinity. So our domain here would be negative infinity to infinity, right? We have no domain restrictions that would happen with that. Okay? If we find g of f of x, now notice this one is asking us to go the opposite direction. G is first. So in this case, the f of x is the input here. Okay? So I'm going to start with the g of x. Right, so in my g of x, we've got 4 minus x squared, but instead of x, I'm going to put my set of parentheses and it's blank. Now, the f of x is the input, so the x plus 2 is what I'm going to plug in my parentheses. Now, on this one, we have a little bit more simplifying that we need to do. Notice I have a binomial squared. When you have a binomial squared, that means you square the first, square the last, twice the product of the middle. So our product is 2x, so twice that, so then 4x. Okay. Now that was just squared, so I still have the 4 minus x, which means that I have this -1 out in front, so I need to distribute that negative to all 3 parts. So then I get 4 minus x squared minus 4x minus 4. So now I combine my like terms. The 4 and the 4 are like terms. Sorry, the 4 and the -4 are like terms. So we get negative x squared minus 4x plus nothing. Right? So then this is our end result for g of f of x. Okay. Now, if we look at our domain again, they again are both parabolas, so there's no domain restriction from f of x being our input. And the end result that we get is also a parabola, so there's no domain restriction from there. So our domain would be -infinity to infinity. Okay. Now, if we look at f of 3, first of all, that seems weird because you're composing a function into itself, but it's still possible. And then we have a number in for the x value. So there's 2 ways you can go about solving this problem. You can start with the f of x, like we've been doing, and find f of x first. So the f of x is the input and also what we're plugging it into. So we have x plus 2, but then I'm plugging in, I'll use a slightly different green color, x plus 2. Right? So then I combine, there's nothing in parentheses I need to do, so then this gives me x plus 4. Right, so this is f of x, right? But the question was, what's f of 3? So now I can plug in 3 into my x value. So f of 3, then I do 3 plus the 4, which then gives us 7. So that's one way you can go about it. I would say that's probably the longer route to go. The other way that you can do it is you're looking at f of 3. Right? So the first thing you do is you find f of 3. Well, if I find f of 3, that means that I'm doing 3 plus 2, which is 5. So then I'm going to place this 5 in place of here, so then we have f of 5, because that's what f of 3 was. So then I'm going to find f of 5, so now I plug in 5, and I do 5 plus 2, which gives us 7, which notice was the same thing that we got here. Okay. Both are fine. They obviously get you to the same spot. I don't have a preference with either way. Now notice when we're plugging in f, that's a line, so it's all real numbers for the domain, and we get an answer as a line, so there's no domain problem that we would have with that. If you have just a number that you're looking at, I would only need to make sure that there's not a domain problem with the number that I'm plugging in. Okay, so let's take a look at these other examples that we have. So in this one we have a square root and a squared. Okay, so if we find g of f of x, okay, so we'll say f of x is the sea green and g of x is the blue. Okay, so this means that I'm doing g of f of x. So f of x is my input. So I'm plugging in the f over to here. So I'm going to write my g, the g is the outside one, so I'm going to write that one first. So we're going to do x squared plus 4, but in place of the x, I'm just putting parentheses. And then the f of x is what goes inside. The f of x is just the square root of x. So if I do the square root of x squared, these undo each other, and we're just left with x plus 4. Okay? Now, if we look at the domain for this, for our domain of a square root, remember that we have problems when you plug in negative numbers into underneath a root because it gives you imaginary numbers, right? So what we really want is non-negative numbers underneath here, which means I need it to be greater than or equal to 0. So our domain for the f of x is that x has to be greater than or equal to 0. We write that in interval notation, it would be bracket 0 to infinity. Right? So we have this restriction from f of x. Right? If we look at our output of g of f of x, this is a line, so we don't have any other domain restrictions that we would have following this. So I have this restriction that my x values would have to be greater than or equal to 0 in order to have g of f of x work. Okay? So if we take a look going the other direction and we do f of g of x, that means that g of x is the input. So this time the f of x is the outside function, so I'm going to do the square root of x. But instead of x, I'm going to put parentheses, and then inside is the g of x, which is the input, so x squared plus 4. Okay? Now, a lot of you will be tempted right now that you can take the square root of x squared and you can take the square root of 4, so then you just get x plus 2, but that's not how you take the square root of things. Right? You would have to factor this first, and then just like we would factor down the square root of 20, this would be, we'd break it down to its factors of 4 and 5 and 2 and 2, and then we'd pull out the pairs, right? Well, this factors, hopefully you remember, to x plus 2i and x minus 2i, right? Which those are not the same, so they're not a pair, so I can't take it out. So there's no simplification that I can do of this for our square root of x squared plus 4, right? Now, when we look here on our g of x, this is a parabola, which means that there's no domain restriction here. But if we look at this, I still can't have any of these be negative numbers underneath the root. So what I want to do is I want to take what's underneath the root, and I want to set that greater than or equal to 0. Because if it's less than 0, that means that we get negative numbers and we get imaginary numbers. So then I'm going to solve this to figure out what my restrictions are. So we subtract 4. So we get x squared is greater than or equal to negative 4. Right? So then if we try and take the square root of this, we get x is greater than or equal to plus or minus 2i. Right? Well, these are imaginary numbers that we're ending up with here. So what happens is that there's no domain restriction with this because this is always greater than or equal to 0. Now, and if you think graphically, x squared plus 4, the vertex is up here, so it will always be greater than or equal to 4. So we don't have a domain restriction from this part because of where the parabola is. Okay? So then my domain is just all real numbers. So we don't need this part here, right? Because we didn't get any restriction from that. So then the domain is just negative infinity to infinity. I can plug whatever numbers in there that I want. Okay? So let's try, we'll skip g of g of x, and if we look at g of f of 7, so let's find this by doing g of f of 7, so just doing it numerically instead of algebraically and then numerically. So let's find f of 7. So if we find f of 7, that means I'm plugging in 7 for f. So that means we're going to do the square root of 7, right, which I don't have any simplification that I can do there. So I'm just going to leave it as is. And then we are plugging in this answer into g. So we're doing g of root 7. Well, that means I'm doing root 7 squared plus 4. Well, root 7 squared is just 7, and then plus 4, which gives us 11. So g of f of 7 is 11. Okay. So now let's look at how we do this from a table. Okay, so here we've got our table over here that we're going to use this for. So if I find f of g of 4, okay, that means that g of 4 is what I want to find first. So I'm going to go to my x value of 4, and I'm going to go to g. So g is the green one, so 4 gives me 1. So that means that g of 4 is 1. So now I want to find f of 1 because g of 4 was the 1. So now I'm going to go to the x value of 1, because that's our x value, and I'm going to find f of x, which is the negative 3. So then this gives us negative 3. Okay. Well, let's try where we do a g of f of x. So if we do g of f of 7, so g of f of 7 means that I'm finding f of 7 first. So that means my x value is 7. So I go to my x value of 7. I find f of x because we want the f of x as the input. So I go to f of x, which is the blue one. So that's 3. So that means that f of 7 is 3. Well, so then I'm going to plug the 3 into where f of 7 was. And that means that now I'm finding g of 3. So my x value is 3, so I go to 3. And then I go to the g of x, which is the green one, so 1.5. So then this gives us 1.5. It's the same kind of idea. Instead of using an equation, you're using a table. Well, now we can do that same thing but we can find the inverses with a graph. Or not the inverses, sorry, the composition with a graph. So if we look at f of g of 5, sorry, negative 5, right? Well, this means we're finding g of negative 5 first. So if we look at g of negative 5, remember that negative 5 is our x value. So if we go to negative 5, 1, 2, 3, 4, 5, right? G of negative 5, g of x is the green one. So we go up to where the green one is. So we're right here. So our y value is 1, 2, 3, 4, 5, 6. Right? So that means that g of negative 5 is 6. Well, now I can find f of 6, because that was our g of negative 5. So we're going to go to the x value of 6. 1, 2, 3, 4, 5, 6. And then we're looking at f of x. Well, f of x is the blue one. So that means that this point right here. So if we look at this point, I drew that badly. If we look at this point right here, we're up 1, 2, 3, 4, 5, 6, 7, 8, 9. So g of f of 6 is 9. You don't actually need it in parentheses. I just put it in parentheses. Okay. If we do g of f of 0, so let's look at this one here. So if we do g of f of 0, this is our x value, so I'm going to go to 0, and we want f, so f is the blue one, so we're down at negative 3. So now I want g of 3. So now I'm going to go to my x value of 3. Oh, negative 3. Try 2. I knew something was awry because at 3 we didn't have the information for the graph. So I went back and looked, and then I remembered I dropped a negative. It's a problem I have. So then we have g of negative 3. So 1, 2, 3. And then we're up, it looks like we're at 2. So then our g of negative 3 is 2. So that's how you find inverses with equations, tables, and graphs. Not inverses. Compositions of functions.